Hello, I'm Mandy Chessel from Pragmatic Data Research. This video is about Lineage, and more specifically, how you can use Lineage to answer specific questions about your data and the processes that maintain it. So what is Lineage? Lineage is not one thing. It is a class of queries that enables you to understand where your data is flowing and how it is being processed. The type of query you need depends on the question you need to answer. So let's begin by looking at the behavior of processes. I'm going to use a Jupyter Notebook to issue queries to Egeria. Egeria is an open source project that supports metadata capture and synchronization between tools, as well as a governance engine for maintaining your metadata. These first cells just initialize the Python environment for Egeria and create a client with a valid security token. The next query returns the definition of a demo governance process called the daily process. The diagram shows the different process steps and how they link together. The first step to run retrieves the day of the week and outputs it as a result to the governance engine. The governance engine uses the result to determine the next step and runs it. In this process, there's a different step for each day of the week. If I then run this process, you can see that two steps run, and in fact, if I issue this is the output from the governance engine, and it shows the different steps it's run. So you can see this, the one at the bottom is the first one to run, and it returns a result of Monday. And the second step to run returns an action for Monday is wash. I can also extract a graph to show the execution of this process. So you can see there are 4 instances of this process's execution, and underneath it are the graphs for each of the executions. Notice how different the execution graph is from the shape of the design graph. You're probably thinking that if you run the process often enough, it's possible to derive the design from the different execution paths. This is of course theoretically possible, but it is hard to be sure that all the paths have been run, particularly all of the error paths. Let me illustrate this with the daily process. Say this process is typically run during the weekday, Monday to Friday, and this is what you can see on the left-hand side. The middle graph shows the derived design, and we compare it with the full design on the right. Having details of each execution allows you to check that it's running when it should and whether errors occurred. Having the derived design provides a definition of what normally happens, so it is possible to detect that, although it produced no errors, it did something unexpected. Finally, the full design allows us to ask what-if type questions, such as what if we ran this on a Saturday? So each of the 3 representations of the execution of the process provides value and allows you to answer particular questions. Okay, with these concepts in mind, let's look at some lineage queries. I'm going to start with what is called operational lineage. This is captured through logging as a process runs. Operational lineage differs from standard debug logging in that it focuses on the data that's being processed. For example, it captures details of the datasets that are read, updated, and deleted, along with the number of records processed. Transformations and quality checks can also be logged. OpenLineage is another open source project that provides a standard format for operational lineage. This is the format used by Egeria and other key processing engines such as Apache Flink, Apache Spark, and Apache Airflow. The advantages of a standard format is that an ecosystem of collaborating tools can evolve. For example, Marquez is another open source tool that specializes in the analysis of OpenLineage events. This is Marquez's UI. Here you can see a list of events. Notice that there is an event for the start of a particular step in the process and one when it completes. So you can see here 4 events from our execution of the daily process earlier. We can look inside at each individual event, and you can see which engine produced it. So here's Egeria's URL. You can see the inputs that were supplied and also the outputs. Marquez is also able to construct a graph of the process as it executed, as well as maintain statistics on how often and how successful the processes are during execution. Now let's consider design lineage, and for this we need to switch back to Egeria, since this is stored as metadata. Like Marquez, Egeria is also listening for OpenLineage events and deriving a minimal form of design lineage based on the paths that executed. The full design lineage comes from the capturing of technical metadata, for example, cataloging data stores and their schemas along with details of the processes that operate on them. The relationships found in this technical metadata provide part of the linkage used in Lineage. These are augmented by information from DevOps pipelines and other tools. Experts in the data and processes can add additional relationships in an activity called stitching. For example, this is the technical metadata captured from Unity Catalog, an open source project that governs access to data. Here you can see the default schema that is part of the initial installation of the project. You can see the different types of data sets in the schema and the physical data stores that provide the data to these data sets. For example, this relational table marksheet uniform is backed by this data folder, and the files in that data folder provide the data that's returned when the relational table is queried. This type of lineage shows a call dependency between, say, the table and the folder. So if the folder is removed, the table will not work. Okay, now let's look at another type of lineage graph, and this time it's for a system. So this is the metadata we have about the system MFCTRL9482, which I can tell you is the manufacturing control system in the Austin factory for the Cocoa Pharmaceuticals case studies. And here you can see a number of data flow relationships. And these data flows describe an ETL job that copies data from one server to another. We can see that the server, where the server is located, you can see that that's in Austin, DC, or OSDC, which stands for Austin Data Center, and which computer it's running on, and also the application that's running on this particular server. But the thing that we're really focused on are the data flows. We can also pick another system, so manufacturing planning, and look at its metadata. And so you can see the data flow relationships to MFCTRL 9482, plus other servers that are involved. So looking more broadly, we can see the systems that are both supplying and consuming data from both of these systems. So this particular lineage graph shows a query based around this software server. You can see the manufacturing planning system that we also looked at, plus the systems that are both feeding and consuming data from this system. This type of graph shows the results of analysis of all the lineage data that Egeria has. It is designed to return the information that is likely to be of interest to someone who owns the manufacturing control system. If we request lineage for a different system, you can see the graph changes, although there are elements that are common in both graphs. So let's look at this system here, CocoSUS. And there we are. Here's the manufacturing and MFCTRL 9482 as well. And then here's CocoSUS. The processes that provide the data passing between the systems have been added over time for different business reasons. Information supply chain tags in the lineage relationships can be used to record these evolutions. For example, CocoSUS is a recent addition to support sustainability reporting. We can either request that only lineage from that information supply chain is returned, which you see in this request Here you see a much more limited graph returning, all based around CocoSUS. Or we can request that the information supply chain is highlighted in the original lineage graph, which is shown here. So you can see CocoSUS, you can see these dark lines represent the lineage relationships that are part of the sustainability reporting information supply chain, and then the lighter lines are the original lineage requests that were there prior to that project. Another analysis graph is an edge analysis. This shows the elements at the edge of the known lineage graph. So that's this request here, which I'm going to run. So here we can see that CocoSUS is ultimately supplying the Coco sustainability dashboards, and that these are the systems that are on the edge of the supply side of the graph. The systems that show on this graph are called the ultimate sources and destinations. This type of analysis provides an interesting perspective, but has to be used with care, since it often reflects gaps in the lineage graph rather than the actual origin of data. For example, notice that the Winchester manufacturing control system and the Edmonton manufacturing control system are shown in this graph, but the Austin manufacturing control system, which is the one that we started with, is not here. This is because the Austin factory is involved in a new business initiative called personalized medicine. And we can show this in this graph here. So if we now look, I'm highlighting the work around personalized medicine, which is this piece here. And here is the Austin manufacturing control system in the middle of this. So it doesn't appear on the edge because it's in the middle of the graph. And the fact that we know more about what supplies these systems. And it doesn't mean that the Winchester manufacturing control system and the Edmonton manufacturing control system have no inputs. It's just we have no data on their inputs in this lineage graph. Information supply chains provide business context to lineage. They're modeled separately and then linked into the technical metadata. So let's look at an information supply chain in more detail. Now this is a very busy output, but it does show how we map from an information supply chain definition through to the lineage implementation. So starting on the left-hand side is the definition of the information supply chain itself. You can see its description and its business purpose. The next column in grey shows the information supply chain segments. These divide the information supply chain into different areas of ownership along the information supply chain. So here we've got 3 segments. One is around the data gathering, and that tends to be the business as usual systems that are operating the business, which is where we're extracting information in order to do our sustainability reporting. Then we have the systems that are providing the assessment of the business's sustainability. So these are analysing the levels of CO2 being used based on the activity extracted from the first segment. And then finally, we have the segment that's based around the reporting, so the dashboarding associated with the results of the assessment. Next are the solution components. These were defined during the design phase of the sustainability reporting project. They identify the different types of systems that are required to supply information to the sustainability reporting, plus also the fact that they're going to be gathered into an operational data store, that's CocoSUS. There will be specific calculators running against it, and the results will appear on a dashboard. So this is a summary of the design of the project that supports sustainability reporting. Then finally, on the right-hand side are the systems that provide the implementation. And you can see there's a very strong correspondence between the lineage graph that we've looked at so far, showing the flow of data between the systems, and the original design. And this correspondence is important in terms of showing the business stakeholders of the project that what they originally agreed to in the design is actually what's running in the systems. So in this video, we've looked at many types of lineage graph. From a distance, they look pretty similar, but each are telling their own story. Look out for more videos from PDR as we explore lineage and other metadata management topics. Thank you for listening, and I hope to see you again soon.